Okay, welcome to the keynote talk for the Alumni Awards reception for 2017-2018. When we're picking people, we try to look for our most distinguished alums, and we have quite a few such people who've really made a major mark in their line of work, in their professional careers. But I think this is the first time that we've actually found someone from our very own faculty who is also an alum and has made a mark to that level. So Steve LaValle is one of the preeminent figures in the robotics research community. He has not only revolutionized motion planning, but is also blazing new trails in areas like minimal sensing and virtual reality. His groundbreaking contribution to motion planning is a basic operation that's used in almost all robotic systems today, and it's called the Rapidly Exploding Random Tree, or RRT, which is used in all top robotics libraries in autonomous vehicles, in manufacturing, in humanoid robots, and in fact, even beyond robotics. It's used in areas like protein folding, drug design, automated video game characters, virtual prototyping, architecture, even digital acting uses RRTs. And going beyond robotics, Steve has also created novel solutions to common problems in areas such as navigation, pursuit evasion, target tracking, surveillance, and done so using much cheaper and simpler components than was previously believed to be necessary. And this work in minimal sensing was attractive to Oculus VR, which was looking for an efficient, effective virtual reality headset. So during a leave of absence from Illinois, Steve joined Oculus VR as their principal scientist, and leading their research and development efforts, he helped them tackle topics like head tracking, perceptual psychology, computer vision, sensor calibration, health and safety, automated testing, and optics. It's a really remarkably wide range of work and impact that he had there. He holds a patent on perception-based tracking, which was crucial for reducing the Oculus Rift's perceived tracking latency. And a second patent covers sensor calibration and filtering methods, which are critical for accuracy and low latency. Since returning from Oculus VR after the acquisition by Facebook, Steve has launched CS498, which is a course on virtual reality, which has been remarkably popular, bringing his industry knowledge to the classroom. And more recently, he had also served as a vice president and chief scientist for virtual reality and AR at Huawei. Steve is also the author of 3 books: Planning Algorithms in 2006, Sensing and Filtering, a fresh perspective based on pre-images and information spaces in 2012, and most recently a book on virtual reality in 2017. And his book on planning algorithms, which was the first unified treatment of that topic, has been downloaded over 1 million times since it was published. In 2012, Steve was named a university scholar, which is the highest recognition that the University of Illinois bestows on its researchers. He has also been featured in Robotic Revolution, an exhibit at the Chicago's Museum of Science and Industry that explains robotics to the general public. Steve, of course, is not just a one-time, but a 3-time graduate of the University of Illinois. He got his bachelor's, master's, and PhD in electrical engineering, and has been a computer science faculty member since 2001. As one of the top experts in robot motion planning with industry impact matched by few people, Steve is truly a major asset to this department. Please help me give him a warm welcome.
Okay, thank you very much. Appreciate the very kind introduction, and very excited to be here, and very much want to congratulate the alumni who came here, and congratulate them for their awards and the outstanding work they've done, and the efforts in making us all look great. I appreciate very much Vikram's introduction. You've covered a lot of the things I was going to explain a little bit. I wanted to start off the first maybe half or maybe a bit more of my talk just going over what I was thinking at different times of my life and just kind of give some perspective and how the University of Illinois impacted me in my development. Let me grab the slide advancer. There we go. It's supposed to be a secret thing. Okay. So I decided to call this Rapidly Exploring Random Life. I'll explain why. I guess in preparing this talk, I realized that that algorithm and the way I tend to do research or work in general tend to be kind of similar in mentality, so I thought I would pull that together and explain that. When I was about 12 years old, I remember this song being popular, and it's like a cynical, retrospective view on life, like how did I get here? Why do we want all these kinds of things in our careers and our lives and such? And 37 years later, I sort of get what he was talking about. It's very interesting. So the lyrics make more sense the more you live, I guess. When I was 12, it was just kind of a wacky, unusual song. This is what I was doing around the early 80s. I spent a lot of time living in video arcades. In those days, you had to pump quarters into the machines. And I loved Donkey Kong, loved Tron, the movie especially. And it had the glorification of something called programmers. And that just seemed amazing. What a cool and nerdy, fun thing to do. I didn't know anything about it. I grew up in St. Louis, working class family. My dad was a printing press operator. We really didn't have a lot of money, didn't really know much about technology. I started programming at Kmart on the TI 99-4A. The sales guy, really nice man there, just let me stand there for hours writing code. So I got a book at Radio Shack and just kept writing programs there in BASIC. Eventually I realized it's too slow and had to do some assembly language work. But I mostly did that by going to friends' houses who were cool enough to have a Commodore 64 that I could play with. But, so that's kind of how things were at the time, and it was difficult for me. I didn't really think about advanced education or really any kind of education. I was in middle school then, 8th grade. I remember the headmaster of the school quite seriously told my dad I'd almost certainly be in prison by the time I'm 17 or 18. And every once in a while I Google and look for people from my neighborhood, and quite a few have been in and out of prison, but I still have managed to avoid that. A few years later, I was a junior in high school. I started working very hard, trying hard in school. I wanted that glorious life of the programmer that I had seen. And then my high school guidance counselor said, you ought to be an engineer. And by 1985, I was 16, and I thought those were the people who drive trains. I really didn't know anything about engineering. He said, no, you should do that. And we have a top in the country engineering school in Rolla, Missouri. And he pulled out a Peterson's guide and started looking through it. I'd never seen anything like that before. So I looked with him, and it listed the top 50 schools. Rolla wasn't on there. It's a great school, but it wasn't on his list of top 50. He was convinced it was the top. He was kind of confused. While he was puzzled, I looked, and I remember the list looking like this. And I thought MIT, Stanford, those are both infinitely far away and only for very, very rich people. That's kind of how I remember thinking. And then I thought, Illinois, that's the name of that state that's only a few miles away that nobody really goes to very much. But I wonder about that. So I asked my guidance counselor, and he goes, oh, I don't know too much about that school. I'm not sure if it's any good. And I go, well, dude, your book, I didn't say it, but I'm kind of thinking, okay, but your book, says that it's 3. So so my friend and my best friend and I went in 1985 around May or June, drove up here to the campus. And at that time, I had fairly high ACT scores relative to people around me. I talked to admissions people here. And at home, I had a big shoebox full of letters from different schools inviting me to apply because I had decent scores. Here I talked to people in admissions, and they kind of politely told me to get lost and go back to Missouri. And I thought, wow, this place is good. I was very impressed. So I made that my mission to get in here. Turns out I couldn't afford the out-of-state tuition, and I had to fight for another year or two to eventually be able to attend here. And I came in as a transfer student, but they told me they did not accept transfer students from out of state. So the state boundary became a problem again. So I petitioned to the dean of the College of Engineering at the time, and they said I was the only person admitted in 10 years as an out-of-state transfer student. So it just was a strange, bizarre thing. So I guess I'm lucky to have gotten here at all, really. So I really made this my mission. I guess that kind of little soft rejection I felt when I came here really impressed me. I go, wow, this is an amazing place. So my time here, my enlightenment years when I came here, it was really wonderful. I arrived in spring of '87. I lived over at Bromley Hall, if any of you know that one. I could see the Beckman Institute being built. It was kind of in a final stage with girders. They were hanging a Christmas tree on the top of the girders at some point. I don't know why, as the winter was coming in. And I'd always loved the movie 2001, HAL 9000. I thought, wow, that building's where the HAL 9000 is going to be built. That's incredible. And I did eventually, by 1990, get to work in the Beckman when it was really quite new. I wanted to comment a little bit from my undergrad days. I was in electrical and computer engineering. I picked it because I liked math and physics, and I also liked programming. It looked like a nice mix. I think the kinds of math when you're an undergrad tend to match a lot the basics of engineering. The computer science program didn't have so much of that at the time. And I remember my undergraduate advisor, Franco Preparata, who's a very pure computer scientist in many, many ways. I got lucky enough to have him. He said, you ought to take this thing called algorithms. And I said, okay, because I was kind of complaining. I said, computer science is not too interesting. I took a class or two, sort of okay. So I went and took this algorithms class from Ed Reingold, and Nancy Amato was a graduate student at the time. And interestingly, both Ed Reingold and Nancy Amato, the last couple of years of this event, won outstanding teaching awards as alum and previous faculty. So just a pure coincidence. They were very inspiring to me at the time. And I remember taking the class. I was a computer engineering undergrad, and there were about 40 students in the class, and mostly grad students, some undergrads. And Ed Reingold was, yes? Oh, haven't turned up. In-room mic. Thank you very much. I'm kind of loud, so maybe people hear me, but okay, thank you very much. Is this the right one? Yes. Okay. Oh, yeah, now it's really going. All right. So there were about 40 students in the class, and I remember being terrified. Like, this guy was really energetic, really passionate, and very creative. And wow, it was a new kind of mathematics like I hadn't seen before. It was very intense. It wasn't sort of the electrical engineering mathematics. It felt like it had been kind of baked into the textbooks for quite a few decades, right? And this was like really fresh and exciting. And it was a lot of that mixed with IQ puzzles. He was absolutely terrifying to undergrads. And I remember it wasn't a required class at the time. So there were only about 13 students left about a month or so in. It was me, the computer engineering undergrad, and 12 computer science grad students. And wow, I was scared to death, but I tend to stick with things. And after my first midterm, I had about a 37 or 39% as he was handing it back. And I was honestly in tears. I was so scared, But then it turned out to be an A. And I thought, okay, wow, this guy's awesome, And so I had a wonderful time. And that really inspired me a lot. I wanted to do my PhD here in computer science, but they said my application was one day late, which I still disagree with. And so ECE took me. So my PhD's in ECE because of weird little things like that. Who knows? So I was very, very excited by that. Then I got to work at the Beckman. My PhD advisor was Seth Hutchinson. He was about 8 years older than me. Interestingly, his dad was a printing press operator too. So somehow he ended up being a very good role model for me at that time. And he told me, you can be a professor, and that just seemed so ridiculous to me. I had no idea what, like the professors came from some other planet somewhere. It made no sense to me. But the further I got into things, the more it made sense. And during my years in graduate school, I felt like I went off the deep end. I learned a lot of advanced mathematics. I wrote tons of code. Most of it in Lisp, some of it in C when I couldn't get it fast enough, so I kind of mixed it up. Wonderful times. Also a lot of scholarship. The Beckman Institute had an amazing service. If you just circled some papers you wanted at the back of a paper and just handed into them, the papers would magically show up, run off on a photocopier in your mailbox in a couple of days. So I severely abused that service. And I felt guilty, so I had to read all those papers, and it made me into, I think, quite a scholar. Spent a lot of time in the libraries. Those of you who are students here still maybe don't know what those are, but those, in the old days we had to go there to look up papers and books. It was very important to us. It was not like Wikipedia. It was very, when you found the right book or paper, you felt like you really accomplished something. You had to do a lot of work. So I'm not sure what all the consequences are of that in modern times, but it's a different culture. Pros and cons. And I eventually graduated with a PhD in electrical engineering, robotics area. It was not a hot field then. Had about 20 publications, many top journal papers across computer vision, robotics, top conferences. Applied to about 50 places for academic positions, no interest whatsoever, no interviews, nothing. So I defended my thesis. I was about to just drive back to Missouri and look around for something to do, maybe operate printing presses, who knows, right? I wasn't sure what to do. And I ended up getting a postdoc offer from Stanford with the top person in the field, Jean-Claude Latome at the time. So I got my dream job all of a sudden. So I said, okay, so I drove to California instead, sort of like Beverly Hillbilly style, went off to California like you're supposed to do. I struck it rich in terms of academics. I thought we'd do the HAL 9000, but these are the computers they made us work with at the Beckman in the early 90s, right? So it was kind of difficult, right? I'm just kidding, that's the Iliac one. I just was looking around for pictures. We had Spark workstations and things, but we were using Solaris and things like that. So we had cool stuff, but I thought that was pretty funny. In any case, no matter what we had, the HAL 9000, we're still waiting on that, right? That level of AI, although things have really turned up a lot. What else? So I did motion planning research for quite a bit, as Vikram said. And I did a lot of work in my PhD thesis that unified electrical engineering kinds of concepts like control theory, dynamical systems with computation and planning. Things like calculating vector fields and cost-to-go functions with obstacles. So it was an interesting kind of mix of combinatorial things and numerical things and mathematical things. Continuous math, which you were not supposed to like too much back in those days if you were doing computer science. Now it's more acceptable, but back then it sort of put you in a bucket. If you like differential equations, you don't belong in computer science. A little bit of that feeling. Although this department has a strong tradition in scientific computing, so I have to be careful. It certainly was true and certainly acceptable there quite a bit. Maybe less so at Stanford, for example. Oh no, that university has a strong tradition too. All right, I'm going to be careful how much I generalize. I became a world-leading expert on playing the game of hide and seek. So I like to. I mean, it's not as too serious of a thing, but that's a lot of fun. So if you have to search a cave with a lantern for people that are moving around, how do you systematically do it so that you can find them even if they sneak back to places where you've already searched? We got interested in that because of mobile robot questions. Interestingly, at that time, I wrote a paper with Leo Gibas, the developer of red black trees, and Rajiv Motwani, who pioneered, largely pioneered and led the area of randomized algorithms, along with a few other folks, of course. And at the same time, Rajiv Motwani co-wrote a paper with the word PageRank in the title. That one was a little more successful, probably, but I really still like this paper a lot, this pursuit of Asian stuff. But I thought it was pretty interesting that the paper that was the basis of Google was done right around the same time. While I was here at Beckman, they were doing Netscape upstairs at the same time. So I sort of felt like Forrest Gump a couple of times in my life, like very close to the really big things going on, right? Just watching the industry grow and wow, that's cool. I don't want to do that though, you know. So I had chances to get into things early, but I thought, no, I really like what I'm doing. Eventually, I did these RRTs, which I'll explain a bit, and then I started questioning whether randomness was valuable at all. That annoyed a lot of my colleagues. I was even attacking my own work for a while. It's fine. I think it's okay to do that. You know, I like to just keep on wandering and trying new things and learning new things. So a little bit about motion planning. You want to do something like tell a human or humanoid or virtual human start in some position like this and say reach into the, that's a little refrigerator down there, reach into the refrigerator and grab something and pull it back up again, but don't hit anything along the way, grab the right thing. You have to figure out how to move all the joints automatically. Nobody wants to use a joystick and control all of those motions. So that boils down to a search in some kind of high-dimensional space. And a lot of different methods have been proposed, a lot of very complicated methods. Random walks ended up being very useful to a large extent in a lot of methods, just as you see them in computational methods, numerical methods all over the place. You see random walks and randomness used, Monte Carlo methods, and physics has been a large source of inspiration for a lot of the kind of algorithms we use. But in some sense, that's just recycling. Those methods or models were useful in physics. We bring them in and try them out in our algorithms in computer science, but I wanted to really think about the problem very carefully. And after 2 years of kind of thinking about it in the background, one day it just kind of hit me very quickly, and I coded that night, and some beautiful pictures were made, and I'll show you a little bit about how that looked. So the idea is you have a space that you want to explore because you're trying to get from point A to point B, and you want to explore it efficiently, and it's high dimensional, and there's bad places that you don't want to go into, but you don't have an exact, let's say, explicit representation of those. You only know it's bad if you're in it. It's kind of like that. Life is like that sometimes too, right? So let's see. And so there's two kinds of processes here. You start off at some point, and then you iteratively pick a point to expand from, a vertex, and then just go in some random direction. Now you have two vertices. Now you pick one of those two vertices at random, go in a random direction. That would be a random tree if we did something like that. If you try that in simulation, just stepping along like that, oh, I see. This thing is, you get a jumble like that. It doesn't really explore anything. Even though it feels very random, I picked a vertex at random and I go in a random direction, there's still a huge bias to not explore, even though it feels like you're doing something very uniformly random. So that's kind of counterintuitive. So I did something that looks like this when it explores, and it's very simple. In 2 dimensions, by the way, it's very easy to do things that are better than this. But this was designed to work in dimensions 6, 10, 20, 100. Some people at MIT used it up to 1,000 dimensions. So there's all kinds of dimensionality games and things like that. That's how it looks with a smaller step size. And people applied it to all kinds of things. And it very aggressively explores in the beginning. Sorry, I don't have animations. And then it just kind of gradually fills things in. And you can add constraints to it, like suppose you have a car that has to make very smooth kinds of motions. It's very easy. Just when you step along as you grow, you just follow the constraints. You use, it's a differential equation, you integrate it, and you move forward in ways that the system allows. So you can do weird things like, suppose I want to drive a car from this place to this place, In this case, I made a kind of ludicrous example where the car can only go forward and only turn left. But it turns left in different amounts. Imagine if you're in a parking lot with a broken car like that. You could turn this into some kind of carnival game or something. You need to clear all the people out probably. And so it automatically finds this weird solution that will take you from point A to point B without any other effort, right? So it just automatically gives that. So that's the kind of things it's useful for. Okay, that's not useful, that's just amusement, but it gives you an idea of the kind of things that can be done. Could be flying spacecraft and humanoid robots and autonomous cars and stuff like that. But those kind of things were coming along 20 years later. So the way the method works is you just pick a point at random in the space, not in the tree. So in the space that you'd like to explore, a point just pops up and says, you need to pull the tree towards me. And so you find the nearest point in the tree and you just try to drive the tree towards that point. And that's all you do, and you just iterate. So very, very simple method, just kind of seemed to elude a lot of the researchers at the time. And I got lucky like that. I thought about it for a very long time. It was very slow. It's like the rabbit in the turtle race. I was just slowly plodding along, but eventually I find a very simple method. And there's some other issues you can do to make it faster, other methods and things you can use to make it faster. To understand how it works, there's this thing called a Voronoi diagram, which is, if I just take, say the blue dots are the various Jimmy Johns around, pick a local, Jimmy John's headquartered here, so that'd be good. I thought about Papa Del's, but there's not enough of them for the figure, and there's too many Starbucks, so I picked this. And so the blue dots are that, and then if you divide up the world based on which one's closest, when a random point falls in, then the size of each one of those regions or cells corresponds to the probability that that vertex is chosen for exploration. So the important thing is the balance between the frontier, where the arrows are all pointing out, and the interior. And so when you look at it like that, you have the interior, you have the exterior, and this is when I start to think about how this rapidly exploring random life and the RRT are kind of similar in the sense that, I imagine that by being here and getting exposed to so many things, it kind of grew the space. We often say that people don't know what they don't know, right? And you go through education here, especially all the way to PhD like I did, it's quite humiliating. You realize there's so many things. And as a professor, it gets even further like that. So I feel like what I know is a very tiny space, and there's just things pulling on me all the time. And the randomness is just, well, maybe an opportunity comes along, like Oculus was like that, or I just meet a great colleague, maybe a math colleague, a theoretical computer scientist, it could be an electrical engineer, all different kinds of people I run into. And I go, wow, that's really interesting. And I get pulled off in some random direction. And I get pulled back and forth. I can jump from place to place a lot because this job gives a lot of freedom like that. So that's why I think my way of exploring is a lot like these trees. So after that, I started getting more and more into mathematical foundations and theoretical kinds of things. I like to say fundamental research rather than theoretical. I'm not really sure what theoretical means all the time, but fundamental questions at least. Try to ask fundamental questions. And I like to think that I moved back and forth with a period of about 16 years of going from very fundamental work to very experimental work. When I get too fundamental or mathematical, it gets really pretty, but then I wonder if I'm doing anything relevant anymore. And then I start swinging the other way and doing more experimenting and hacking. And if I go too far into that, I wonder if I'm just kind of making a mess and not really able to extract some fundamentals from it. So I like going back and forth like that over the time. And I think my period's about 16 years. I might be slowing down, who knows. Maybe it's going to be 20 next. I don't know, but that's kind of how I feel. And it's been great. During this time especially, I had so many brilliant PhD students working together with me, and I'm sorry I didn't produce a good picture of them. I meant to do that and didn't get to that. And at a given time, I'd have about 6 or 7 PhD students, a few undergrads and master's students hanging around. It was really great critical mass in those days. And we had this amazing DARPA program. They funded us $8 million, and we handpicked about 12 to 15 researchers, some pure mathematicians who have never done anything applied before. Robert Geist was in the math department here, and he liked topology and robotics, and I liked robotics and topology, so we got together, and we pitched this program to DARPA, and it was just really incredible. We did a lot of interesting work on the foundations of sensing. So moving along from that, I have this book I produced during the early part of that period, and I strongly believed in giving away things for free on the internet, including software libraries and things. But this book, that's how I got into Oculus. They were just doing a Google search for certain key terms and found parts of my book. I didn't know them from anywhere. I'm not known in the game industry or anything like that. This is like a mini book. I was hoping to write a bigger book on sensing and filtering and the mathematical foundations of that. But while I was doing that, I got distracted by Oculus, which I was going to say, but I forgot about this as well. I also got very excited. I could feel the experimental urge coming on, and I started playing around a lot with a problem called the dynamical billiards and ergodicity. It should be ergodicity. Yeah, egodicity is kind of funny. So, but that's a problem professors suffer from, you know. But anyway, ergodicity, which came from very advanced Russian mathematics. And eventually I was fascinated by these little things called weasel balls that just have an offset motor in them. And as they rotate at about 2 hertz, they wander around and look like they're very intelligently exploring. So we figured out how to herd weasel balls and then make robots that are simulating those very simple mechanisms. And we could herd robots around a lot like people are herded through turnstiles or security checkpoints at airports and things like that. So I thought that was really kind of fascinating. I was just about to ramp up even more in that, and then well, this Oculus thing happened, and I thought, wow, I better jump into this because I played the Forrest Gump kind of twice, and I thought, wow, this one, 3rd time's a charm maybe. Maybe I'll actually jump in. I was already a full professor. What's left for full professors to do in some sense? I'd been the graduate program director for a few years. That was very rewarding. I'm afraid of things like Vikram's job, being head of department or deans of things of that nature. That scares me a lot. So run away, go to a company, see what it's like there. So that was very exciting. And after that, it was such a fast success. It happened really very quickly. And came back, learned a lot about angel investing, advising venture capitalist startups. And the local community here and the Chicago community were very welcoming to me. I met many people, many business leaders, mayor of Chicago, many other folks. Peter Fox here in town has been a very big business leader, and a number of other folks. So that's been really great. Also connections back to Silicon Valley as well. And so that was great. And then about 1.5 years ago, Huawei approached me and wanted me to lead their VR, AR efforts. And in there I learned all kinds of interesting things about product development in a big company, connecting product and research, and how a company can function across over 100 different countries. And that was fascinating. Huawei's a world-leading company, and it's famous everywhere except the United States. So if you run around in Europe, they're like, oh yeah, Huawei, we have Huawei phones, and we have Huawei this, and we have this Huawei center down the street, and all of these things. But in the US, it's not as known. But anyway, it was very international and very interesting. And spent a lot of time going to China. I lived there this past summer, and learned a lot of cultures. Fascinating, fascinating world. So I gained a lot from that. At the end, though, I decided, I kind of weighing everything carefully, I still lean more towards academic kinds of fun. Let's see. So a couple of quick things about Oculus. This is how fast it happened. So Palmer Luckey, 19-year-old, started the company. You've maybe seen the news from that. After the Kickstarter campaign, they needed to make things work really fast. 3 days later, I was already starting to work with them. And we quickly shipped a development kit. It was manufactured in southern China. And the value of the company grew insanely fast. As I started talking to venture capitalists later, they pointed out that this is not very common. I don't know if it's easy or hard or not, but I can see now after talking with a lot of companies and learning a lot more about the ecosystem that this is pretty darn hard. So maybe I got lucky and picked a good one. Of course there's some luck involved, but I also had the responsibility of making things work. I was very interested in that, and I thought I could based on my background. Even though I never worked specifically with these kinds of sensors or with VR at all, just working with the fundamental background that I had, I thought it was doable. And I would say barely a good enough coder to be able to write the C++ software that was required for the SDK. Had I not been, they probably would not even have accepted me. They're just like, no, you can't write the code we want, you're useless, get out. And so it's like that in a small company, especially if you need to get things going fast. And so that's interesting. And after the company was bought by Facebook for $2 billion, turns out it was $3 billion. You can check the news on that. But a lot of interesting stories we can talk about at dinner if you like. And then I returned back here. My wife, Anna Yershova, she's a teaching professor in the department here. We both worked at Oculus together. And actually the first part that we did was in an apartment in Finland because I was on sabbatical trying to write a big book about all the sensing work, especially from that big DARPA program I mentioned. So that book is now frozen after 3 chapters. It's frozen somewhere in the near Arctic of Finland, waiting to be thawed out and continued sometime, I'm not sure. So I got into the kind of things, as Vikram already mentioned, predictive tracking and these kinds of things. So really making the headsets have 0 effective latency was very important, especially from a perceptual standpoint. I'll come back to that in a bit. And of course, the course here, I'm glad that the alums here were able to go and tour our lab that we founded. And the course mixes human perception and physiology with the software and hardware engineering as much as we can. Maybe hardware not so much. It's hard to just design new hardware and get it working in a class. But that's the things we do. And again, give away a free book. The University of Illinois is very excited about MOOCs, the massive online open courseware. That scared me a little bit, so I just ran to India really quickly and did a MOOC at IIT Madras in 2015, all in 2 weeks. So a huge amount of fun. And so I do have a MOOC, but it's at the National, I don't know what it stands for, but what is it, National Program for, okay, I'm not going to get it right. But in any case, you can look for that. It's a program in India, and it's available everywhere. The videos are all on YouTube. So if you want to see my course lectures, you can find it there as well. I'm not sure if that counts for having done a MOOC here. Probably not. Probably they're still going to say, hey, Steve, you should do a MOOC. So, yeah, exactly. Yeah, talk to my friends at IIT Madras. Oh, okay. So here's some general lessons, I guess. So one thing I like to say to students a lot of students wonder about trends or what should they be studying and things like that. First thing is learn the deepest stuff you can and as much as you can early on. And hopefully it's based on curiosity more than worrying about trends so that you're very naturally motivated to do it. If there's some things you're not good at, but they might stop you from getting to the next level, you'd better put some time into those too. I was terrible at speaking. Maybe I'm still terrible at speaking. I'm not sure, but I was absolutely terrified. I had to practice like crazy to do this. So how could I be a professor? It doesn't even seem feasible going back to how I thought in the 1980s. So that's very important. I feel like the world will try to stop you. The older you get, the less opportunities you're going to have. Companies are not going to fund you to just learn cool stuff or really deep and interesting things. You have to make sure the company stays afloat and keeps growing, maybe all the way down to the fiscal quarter, right? So if you're worried about, oh, I'm going to learn this really cool thing and it may or may not be useful 10 years from now, you're not going to get a lot of opportunities to do that except here, right? Or in graduate school or during parts of your education. I generally watch trends with amusement. I try not to take them seriously. I think they're more of a sociological phenomenon. Sure, it's mixed with science and technology, but it still tends to dominate. The social aspect tends to dominate, really. So I've kind of happily ignored trends, and I almost didn't have a job a couple of times because of that. But then it kind of works out. After Oculus, VR, virtual reality, was a big peaking trend, and robotics happened to turn into a trend too while I was at Oculus. So all of a sudden, I'm like an expert in a couple of areas that are very trendy. It's just an accident. I wasn't trying to chase the trends. So I really try not to take trends too seriously. A little bit if it's necessary once in a while, but not too much. And I feel like culture is everything. I'll say this, it's something really important to me. I deeply find culture very interesting, whether it's languages in the world, going to other countries. Growing up in Missouri, I never could travel anywhere. My parents never left the state of Missouri even. I think we went over to Illinois once, just a couple of miles in because I kept complaining. And it was only 10 miles away, come on. So I love traveling. And I feel the same kind of thing happens in academia as well. We have electrical engineering culture and physics culture and computer science culture, and there's UIUC culture versus Stanford culture, and then there's robotics culture versus algorithms versus control theory and so forth and so on. So I think most of us, most of the time, are largely oblivious to it. We know there's culture, but we tend to operate in certain ways, and there are default expectations and language and values that just sort of happen, and we're hardly aware of it. When I was younger, especially in my 20s, I was much more of mode number 2. I was very respecting of other cultures and tried very hard to learn them from the inside, just to embed myself in them and say, okay, let's just pretend I live here now, and I always have, and I tried to learn from that. By the time I got older, I sort of realized that they're all pretty arbitrary. And I respect the people that are inside of them, and they may or may not be at different levels of realizing this or focusing on this, but I feel like they're all pretty random and arbitrary, and I try not to take them too seriously and try not to insult people too much inside of them. But mostly I'm just kind of watching, going, yeah, I get why everybody's doing this right now, but it's pretty random and arbitrary and it's cultural, but that's fine. I don't blame you for it, it's fine. It'd be nice to maybe push this way once in a while, but that's how it looks to me. So I kind of disrespect culture, but I respect the people inside of it. And not everyone has the opportunity to experience multiple cultures, whether it's in the world or whether it's different academic disciplines, whether it's industry culture versus academic culture. And again, companies each have culture, and then departments within companies have culture. So I really take this part very seriously. At some point, too, one sort of final thing here on the general lessons is I started thinking about what kind of research I like. And I always tell my students and colleagues that I like things that are beautiful or useful. And they don't have to be both. Every once in a while, they're both. But simply impressive, like, oh, wow, that looked really hard, or that must have taken a genius to do that, it's fine, but I don't care too much most of the time. I'm more attracted by the beauty, or this thing's really useful. Sometimes you get both. I think Claude Shannon's paper on information theory really strikes me as both. It's absolutely brilliant and beautiful and simple and extremely useful. Maybe the closest thing I've gotten to in my career is that RRT is like that. It's very simple, not as cool as Claude Shannon's information theory, but it's something that's very simple, easy to explain, wasn't there before, and ends up being very useful. So that's the kind of thing to really strive for. But either one of these is fine. If it's neither, I have a problem. But either one of those is fine. I'll tolerate ugly things that are useful, and pretty things that appear useless at the time is quite fine. There's a reason why there's some intrinsic beauty to it. There's probably something useful in there in the future. It's happened so many times. Number theory being a good one, right? 100 years or so ago, it didn't seem so useful. now it's quite useful everywhere. Different cryptography and currencies and all kinds of things like that. Academia versus industry. Here's some things I've learned by going back and forth. And again, I've spent most of my time in academia. I don't think of myself as being well balanced in that sense, but it's sort of more like a professor's view of how industry looks. I found mutual disrespect from both sides, and neither one respects the other all too much. There's always exceptions, of course, but I'm amazed at the amount of, those university types, they're useless, whatever. They overcomplicate everything. And then from the professor's side, it's like, those people in industry, they don't understand what they're doing. They're running around in circles, It's just a lot of mutual disrespect. I feel like academics should listen to industry problems, but not just follow exactly what they say, but maybe develop a good relationship or dialogue and help reshape some of the problems they're working on through mutual respect, hopefully. One thing that really struck me is that in academia, we have shared information pretty much, right? I mean, maybe Vikram knows a few secrets that nobody else can know because he's the department head, but for the most part, everybody kind of knows what's going on, and we can all ask and share information. We certainly know about the technical subjects very well. In a company, well, you're battling other companies, and there's information walls put up. And then inside of companies, I've noticed that there's walls there too, because people are competing for resources. And so when you don't have shared information, it starts to make all kinds of difficult struggles and battles and reinventing things and confusion and chaos. And gosh, that was really difficult. So I found that really interesting. And so I like just simply explaining things. I think also this thing of helping people. I love helping people and explaining things to student after student, working with colleagues. We teach each other things. And in industry, I tended to be very much like that. And a lot of times it's very well appreciated and it worked out very well, but sometimes it backfires too. Like, oh no, you shouldn't help those people. You're supposed to help those people. If you help them, then they'll get the resources and we won't. And all kinds of things like that tend to happen. So sure, it can happen in academia like that a little bit, but I really felt like because of this closed information versus shared information, it seems like it opens up more opportunity like that. Let's see. I was also amazed that in talking to venture capitalists and large companies, there was more of a herd mentality than I would have guessed, because I thought that in industry, the criterion is very clear. Make money, at the very least. Okay, also hopefully do better for humanity and so forth and so on, but at the very least, you have a clear goal. I mean, the company has to make money. Everyone hopefully shares in the profits of that if it's a well-run company. And that's great. But I was really amazed at how much it moves along in herds. And academics fall the same way in that. There's academic trend after academic trend. Very often, they just rename something that fell out of favor 5 or 10 years before, but it's kind of the same problem. And maybe it gets shaped a little bit. So we're all prone to that. But it was amazing to me that happens with venture capitalists. And I think one of the reasons is FOMO. Anybody know FOMO? It's a fear of missing out. So if you see a bunch of people doing something, if you don't invest in it, but they did, if the trend fails, fine, everybody forgets. But if the trend succeeds and you did not invest in it, then you'll have a bunch of people like the limited partners who invested in the venture capital fund are going to complain, I thought I picked a smart venture capitalist and you didn't invest in this. So it tends to cause people to gravitate towards a herd mentality. I also think there's less time to just sit and think about the fundamentals in a company, because if you do, you'll go out of business if you just sit and only think about fundamentals. So it's understandable. I don't mean anything disrespectful, but it's just I can see how the culture is like that. I didn't think it would have been like that, but that's how it tends to be. Giving away stuff for free seems to be very appreciated in both industry and academia, and I found that cool. I like giving away books. We gave away software at Oculus. We wrote free kind of scientific blogs and other things like that I worked on, and I think that's very well appreciated. It stimulates the growth of a market either way. So that was interesting, and that was the same both ways. And wow, in industry, if a company decides to move in one direction, it's amazing having a bunch of brilliant, well-trained engineers all lined up and moving forward on something. There's nothing like that in academia, so that's quite impressive to see. So that's something that, wow, if you can really get everything aligned, especially if taking herds and things like that into account, if you can really push the trend and push a new trend and get things moving, it's incredible what can be accomplished. And just generally, and this is not industry versus academia, this is something I've just kind of seen across my entire life, and I see it a lot, especially in this Wikipedia smartphone-oriented culture that we have, is the Dunning-Kruger effect. Anybody seen this before? Oh, great. Well, so here it is. It comes from social psychology. People with a low skill level have illusory superiority. Right? So if you just quickly scan on Wikipedia a little bit, you can sound very impressive in a meeting, let's say, right? Like, oh yeah, I know this stuff, bam, bam, bam. If you study something very, very carefully over maybe many, many years or decades, you start to forget that what you know and you think is simple is actually not simple for the people who have not studied it. And it's very easy for the expert to have low confidence. and the novice has a lot of confidence. And I saw this again and again when I was at Oculus and other places. It's very, very interesting, and it's hard for me. I mean, I found that very difficult because business leaders, CEOs like simple black and white answers, and an experienced, well-trained academic will say, well, this problem's really hard, this could happen or that could happen, I'm not really sure if this will work, and you sound very uncertain. So it's very interesting how that works. The dynamics of the Dunning-Kruger effect I found were extremely valuable to understand that and then try to compensate based on that. So that's something I learned. So I'm going to go to the second part. And I hope that was an interesting enough comparison. I said I'm more academically oriented, so maybe it wasn't so balanced, but at least shows like what it's like for an old professor to go to companies and then come back and talk about it, to give you some idea. This one's just kind of in general. This also probably fits what they say. We always said this when I was in graduate school, that after a bachelor's degree, you feel like you know it all, like I've learned the stuff in the books. After a master's, you realize there's some stuff you don't know. And after a PhD, you realize you don't know anything. Right? And after being a professor for decades, wow, I'm really clueless, you know? It's incredible how much is out there. Again, it's that the big Voronoi regions of all the things out there. It's enormous. So I don't have a lot of confidence. Let's see. So let me talk about, with the last 15 minutes or so, give you some VR perspective. Just switching, no more storytelling too much, but just more like industry perspective on virtual reality. It's an old subject, goes back to, maybe it goes back for as long as you like. In my book, I trace it back 30,000 years to cave paintings, but depends on where you want to draw the boundaries. But Ivan Sutherland's Sword of Damocles was a VR or AR, augmented reality kind of display, 1968. That's the year I was born, so it's a fair amount of time ago. Jaron Lanier in the 1980s really popularized VR. That was the last big run of VR. University of Illinois at Chicago, and then here at the Beckman Institute, built these big cave systems and pioneered that. Professor John Hart, who's on the faculty here, was a graduate student at that time and also contributed to that. Then came the movie Lawnmower Man from Brett Leonard, the director. I've had a chance to talk with him quite a bit in the last year or two. He's hoping to have this, to have the next generation of storytelling with this new medium. But he was very active at that time. And then came the financial death of the VR movement with consumers called Nintendo Virtual Boy. And that let companies know to stay away from VR for a long time because this product didn't work too well. Has anyone had a chance to try that? Anyone ever? That's great. What did you think?
It was fun for 15 minutes.
That's good, 15 minutes. Now maybe we're up to an hour, right, with the current VR headsets. Hopefully better than that, but that's right. A lot of people got headaches. It was just red lines against a black background. It was stereoscopic, and it did not do head tracking. You put your face up to it. I'm not sure if that was VR or not, but VR took the blame, let's say. One thing I was familiar with as a roboticist is that the component technology was not ready yet. But when Palmer Luckey started his company, the design was based on smartphone screens and smartphone sensors, the MEMS technology inside of the sensors, and the modern computation units, GPUs and CPUs on the smartphones. So, well, actually, the GPU for Oculus was the PC-based graphics cards, now that I think about it, but everything's gone mobile now, so it continues. So the component technology was very important for advancing robotics and continues to be, so I knew that. Even though I'm a computer scientist, I also knew that having the right components, we just rely on these magical components, right? You give somebody a computer, they start programming, they don't think about the components necessarily too much and how to change them around to make life better. Absolutely critical in robotics, absolutely critical in VR. So 2016 was the VR consumer revolution. Maybe they said 2014 was, and then they said 2015, and then 2016 was. What year is it now? I forget. 2017, right? I think. So it's 2017 now. They're not saying that anymore now. They're going, wow, it didn't really take off like we thought. Huawei jumped in as well, and there's a lot of companies in the mobile space kind of adapting their smartphones, either dropping their smartphones into a case or just taking the component technology they have and scrambling it around. A lot of impressive chip makers have jumped in as well. Qualcomm has done a lot in this space, for example. Here's the problem, though. They're waiting for the killer app. What is this thing good for? What is this technology really going to be used for that motivates everyone to just jump in and hang out there for long periods of time and keep going back to it, rather than a cool 15-minute, like, wow, that was fun and I'm done now, right? So we sort of knew that was the problem at Oculus. Here it is a few years later, and it hasn't seemed to fully happen. Why is that? Let's talk about that. Well, they started adapting what they knew. So they did first-person shooter games. It's easy to do that. You already have all the information, the geometry of these worlds. It's already there. You just step into the game. Well, you step into the game, and after a few minutes, you want to vomit, it turns out, in a lot of cases. It makes it very sickening. Also, people who are playing with a keyboard and mouse can kill you much faster than someone who's in VR because the game was designed to be faster than reality. So a lot of subtleties like it. So it's very easy to make stuff, but it's not easy to make stuff that's overwhelmingly compelling, that really makes it so that people want to jump in. All kinds of interesting panorama, street view kinds of things. One of the times when Anna Yershova was teaching the VR course, there was interest at the campus level in making a panoramic tour of the campus. And so that's available online now on YouTube. That's very interesting. Communicating designs in architecture or in engineering, very important. So there's all these use cases. This one's not consumer completely, although consumers would like to see what their home remodeling would look like or real estate purchases might look like. But the device you're selling might just go to a real estate agent perhaps or to a building company. Socializing, of course, Facebook's very interested in that. We're all very interested in that. You can sometimes do things that are better than reality in virtual reality. Like, for example, if this were a VR kind of lecture, I could look at each and every one of you simultaneously, right? Because in your view, I'm looking at you. And maybe I can only look at one of you at a given time, but just the fear that I might be looking at you would be enough. Of course, you could fool me and you could be sleeping with your avatar awake, and there's all kinds of games you could play. It would turn into an arms race, like radar detectors and things like that, but that's fine. So a lot of interesting possibilities here. And so there's a lot of uses. Here's what I see a lot talking to investors, hanging out in companies. This is kind of stuff is less familiar to academics, but more familiar to people in industry, certainly in venture capital. This is the Gartner hype cycle. Anyone heard of that? Yeah, so people have been around industry for a while, know these things. This was 15 months ago, machine learning at the absolute peak, augmented reality about to hit the bottom, and virtual reality kind of clawing its way out finally, right? I see some nods, maybe people of disbelief, who knows? It's amusing to see these things. I'm not sure always what to make of them, but people take this very seriously. It also contributes to the herd mentality, right? Oh, this is smart, this is good, we follow this, So who knows what the cause and effect is, but this is what people pay attention to. But then this happened at the same time 15 months ago, Pokemon Go. This crazy thing that came and went, but that caused all the companies to change course in this space. And yet, I'm not sure if it had anything to do with virtual or augmented reality at all. I think it's a geolocation game. The VR part or AR part was kind of lame, really. It didn't work too well. Maybe it was just a Pokemon phenomenon. There was a critical mass of Pokemon lovers that all of a sudden it spread like wildfire. Maybe that was enough. It's a sociological phenomenon. It hasn't been reproduced in over a year now, and yet companies are investing like crazy. Google has AR Core. Apple has AR Kit. They're hoping people make the killer app for AR on their smartphones. But if you hold your smartphone up for too long, it's not very comfortable. You get what's called gorilla arms. People in interfaces know this. People in AR know this. So I'm not really sure what's going on, but we'll see what happens. They're really hoping that it's going to take off. But that caused a big pivot all of a sudden. So this is how one of these investment kind of slides looks like now, recommendations. Mobile AR software. AR got downgraded to just be something you can do on your phone, like put a mustache on or some makeup or something. It's a lot easier. So they lowered the bar, and they say you don't need some fancy glasses anymore. Just use your phone. So that's a smooth transition. Everyone likes a smooth transition in industry. You can't disrupt things too quickly, right? Otherwise, you have a lot of shareholders angry and things. Let's see. Mobile AR hardware. Next will be fancier sensors doing depth sensing, measuring distances, and providing good three-dimensional data. And then maybe you'll get glasses perhaps connected to your smartphone. So you get some lightweight glasses that hopefully look stylish and cool. And then eventually you'll get to the standalone smart glasses. And Huawei, Google, Samsung, a bunch of companies are in on that and looking at these kinds of things, presumably. Right? No one can know exactly what they're doing, right? The old terms have gotten kind of fused together and confused in some way. So VR, AR, MR, mixed reality, all that came along. I like to give credit to Immanuel Kant, the philosopher for virtual reality. That also I got that background by through a Professor Carl Niekirk, who's in the Germanic Studies department here at U of I. We happen to be friends through our children. And I asked him where'd the term come from, so that's cool. Most people credit it to technologists, but it goes far way back. Augmented reality, mixed reality, those terms meant something very distinctive in the 90s, but today it's getting all kind of blurred together. When Facebook talks about VR, Microsoft talks about AR and MR, it's all kind of looking very similar to me. And one of the reasons why is because the devices can simulate each other, so they're all on a converging path. And because of the proliferation of cameras, because we all carry cameras around, you can take pictures of anything. So I think texture mapping in old computer graphics going back to the 70s was mixed reality. You can take a picture of something and map it on to your graphics. So that happens all over the place now. So everything's mixed in some sense. Even the original virtual reality headset that Ivan Sutherland built in 1960s, people today would call that augmented reality. So there's all this naming and battling for resources. Mostly it's nonsense, drives me crazy, but that's the way it works. Lately in Silicon Valley, people try to gather them all up and say, yeah, all those different R's, that's XR. So fine. But then people say XR has maybe some connotations that a field shouldn't have. So we're not really sure. I have some suggestions as a computer scientist. Why don't we just call it asterisk R, and you can put whatever you like there, right? So just use regular expressions and put a bunch of stuff there. Of course, the business leaders would like to have this. And they're waiting for that, but it hasn't come yet. Not in big enough numbers anyway. All right, so a little bit about product things, and I'll really be finishing up here. So I like to say there's 3 E's for product. I'm using the word XR there. I'm not sure what to use. And so three E's to think about for product success based on the experiences I've had over the last few years: ergonomics, ecosystem, and engineering. And as an engineering professor, as a computer scientist, we tend to think of the engineering part almost exclusively, but the other 2 are really overwhelmingly critical. Otherwise, you're not going to get anywhere. Very often, engineering tends to dominate, and the other 2 get kind of neglected. But it depends on where one's background is, and maybe in some companies, one will dominate and the other ones will fail. So the ultimate display that Ivan Sutherland built looks like some kind of torture device. Oculus product came along, Microsoft HoloLens. You have these Snap spectacles, which are really cool. All they do is take pictures and upload it to your phone. But that's light and stylish and kind of cool. So that's maybe where the devices should be going. So light and stylish, wireless streaming, cloud connected, all of these kinds of things. That's what we should be striving for. Don't try to put everything into the glasses yet. That's what I'm trying to emphasize. Make it do some things really, really well. One thing maybe really, really well that is likely to spread like wildfire, and then we'll be okay. As it is right now, it's just the field is kind of ambiguously defined, so people want to just put everything, including the kitchen sink, on your face, and then it's too heavy and uncomfortable. So you have heat problems and price problems and on and on and on. So that's where a lot of this stumbles. Content. So every company has its favorite content hopefuls. If you're a game company, then you hope for VR gaming or AR gaming. If you're Hollywood, you want to make interactive story worlds or panoramic movies. So everyone's looking at this technology through the lens of what they're most familiar with or how they built their expertise. It took many decades to convert Hollywood from some art movies that lasted a minute or two around the year 1900 up to full-blown Hollywood, methods of cinematography, so forth and so on. It took a lot to make a business out of that, decades. I think the same thing's going to happen here. So the problem is that we just keep recycling the things that we're good at already and just trying to adapt them. It's easy to do that, but it tends to create like micro bubbles. You make something really fast, but then it's not so great. It's cool maybe for 15 minutes, but it's not so great. The investments that go on, the strategies in companies, it's this kind of recycling of content, like I said, like first-person shooter games. Some people are investing, maybe giving money to crazy artists, but those people are going to be very far from a return on investment. But the most exciting things I've seen in this whole space come from pure artists. Absolutely the most provocative, amazing things. I don't have time to go through examples of that. Also, give it away for free. The companies are all giving away software kits. Oculus did that with VR. Google and Apple are doing that with the AR right now, at least on the smartphone. So recycling, I think, is like the universal problem. Just quickly pivoting, taking what we already have, repackaging it, trying to put it together to make something new. And that causes a lot of trouble. That makes these micro bubbles, as I've said. The engineering part, here's the problems. We have displays and rendering issues. I'll mention these very quickly. Interaction mechanisms and distributed computation and communication. So we need to have all of that working well. And we actually are not sure what the performance criteria need to be. Engineers like to know what the performance needs to be. We're not completely sure because we haven't worked out the whole ecosystem and ergonomics part. So all of this really needs to be put together. Like, for example, does your use case involve reading a lot of text? Right? Like, do you want to read Wikipedia in VR? If you do, then you have a display problem right now. It's not very comfortable. Nothing available to consumers on the market is going to work for you. So things like that. So there's a lot of troubles here. So you have to pull all these three together to really solve it. Display issues, we don't have enough resolution. So that's a big deal. we're essentially putting magnifying glasses in front of the screens from smartphones and saying, ooh, I can see pixels again. The older folks here remember seeing pixels, right? You know, it was a wild time. We survived it. It was okay, but you know, we're going through that again. There's also this thing called vergence accommodation mismatch. I won't explain it here, but it's the same thing that happens at the movie theater that causes headaches and the reason why stuff is not in your lap anymore. The characters are behind the screen. So that kind of stuff happens. Need to solve that. The whole world needs to be tracked, so there's all kinds of interesting sensing and robotics kinds of issues to track the world around you, to track you as you move, develop new kinds of controllers, on, and interaction. What is the 3D version of the PC mouse, right? The mouse is amazing. You do very small motions, and it feels like your virtual fingers moving around on the screen. Steve Jobs thought that was pretty important, right, at some point. So did the folks at Xerox PARC, but you know, they didn't have their day with the home PC as Apple did. But that's very important. I feel like we're completely floundering here on that one. A lot of controllers or interaction mechanisms are being designed, and they're basically just take your hands and wave them around until you get tired after 5 minutes. So how do you exploit the power of the mind? I want to do something where you do very small motions, and your virtual body is doing cool stuff. Like, you know, I point over there, and boom, I'm over there. Or I have big, long, rubbery arms. I can do different kinds of things. Depends on the use case again, or the killer app. But I want that to work very well, and I think we're way behind on that one. Let's see. How to distribute the computation. I like to look at it like a cache hierarchy. So how do we distribute things? There's what's on your face, what computation you might be carrying on your body in a pocket or purse, maybe a local base station that has direct line of sight, like this room, maybe something like a Wi-Fi base that you don't have line of sight with. I'm kind of hinting at WiGig and things like that if you're following those kind of movements. And then there's some big cloud server, maybe here, and maybe there's one in Champaign and one in Urbana, or maybe it connects all the way to Norway for some reason. You know, so who knows? All kinds of things like that. And so how to put these computations together and distribute them remains a very fundamental and important problem. So I'm going to run out of time, but I just want to point out that we have to kind of distribute all of that. And it's very difficult when you have to track the movement of your head in order to figure out what to project to the eyes. Premature modularization. This is one of the biggest problems I've seen across industry, is that you have departments and teams that know how to make one thing, and then you put the pieces together to make the product. But this field really requires completely redesigning all the pieces, it turns out, and putting them together in a completely new way. And so if you've modularized your design too early on, it just drives all the requirements up really high, and things tend not to work. They get too heavy, they dissipate, they emanate too much heat, or gather too much heat, they cost too much, so forth and so on. Let's see, oops. Here's the big thing I want to say to conclude my talk. I feel like there's a new field emerging. I hate to keep making more names after the jokes about XR and everything else, but I feel like it's perception engineering. That's a VR-like definition, using technology to design, develop, and deliver perceptual experiences that are tightly integrated with the human senses. And so by that, you know, you have to understand that the organism is part of the system. Scientists do VR on rats and fruit flies and all kinds of things to study their neural activity. So we have to understand when we try VR, we're a lot like that. So you have to know human physiology. That's the hardware. And you have to know perception. That's like the software. We didn't build those systems. We just seem to have them. So we have to reverse engineer those. Luckily, there are scientific fields that do that. So like, for example, when you're looking at that picture, there's a lot of depth information there that your brain is able to work out and your visual system works out. And whatever you make in VR, these other systems, these processes are going to be disrupted in some way. So you have to figure that out. Does that look like it's moving to anybody? It's really creepy, right? There's nothing moving there. So there's a lot of really mysterious processes that are happening. And you have to understand that because there may be small technological artifacts that haven't been worked out, and all of a sudden a bunch of people get nauseated. I get nauseated if I look at that picture enough. And there's nothing strange going on. I can print it out too and say, this piece of paper makes people sick. Like, so is it the hardware, the software, what's going on? So when people are doing development, that's an old Oculus picture, they tend to mix the development with the evaluation, so they become both the scientist and the lab rat together, and they adapt to the whole thing, and it makes a big mess. So separating that out is very hard. That's one of the reasons why there has been problems. Are the headsets good enough? Well, in the old days, they had low everything or high things, just everything bad. Now everything's good. The industry leaders say our headset is so good that it's beaten the sickness problem. I say to them, it's so good that it can make people more sick than ever before. Because as the fidelity improves, you have more opportunities to make people more sick. Like when you move your character in VR virtually, your inner ear knows you're not moving, but your eyes tell you you're moving because of optical flow. So that mismatch will make people sick over and over and over again. And the better the device gets, the more sick you can make people. So don't do that, right? There's an education problem too. I'm almost my last slide. Very simple things. A lot of psychologists talk about perception of motion, right? Our brains are wired to trigger whenever there's some motion in the field of view. Perception of non-motion or perception of stationarity is one of the hardest problems in VR. When I turn my head, I need to perceive what's in the display as being not moving. So that means a bunch of stuff has to move in the display. Sensors are moving through space. A whole bunch of math and algorithms and hardware, all these things have to function to make you perceive that something has not moved, right? Like if I put Vikram into VR and start turning my head back and forth, he's going to be moving across my display. He has to move at exactly the right places and times so that my brain is fooled into thinking he's not moving. So that involves a lot of moving parts, let's say, or components. Maybe not physically moving in the device, although it all moves through space, but it involves a lot of computation. So one final thing to think about. So this perception engineering, it's a transition from science to engineering. So physics went a long time ago to civil engineering, then mechanical engineering, and electrical engineering, aerospace as well. Chemistry goes to chemical engineering, biology to bioengineering. I feel like this is really the time for perception science, and put neuroscience in there with it, to go to perception engineering. I feel like a whole discipline, degree programs, departments, all kinds of things could be organized around this. And it makes a lot of sense where you have the engineering part, which is the red part's usually all we care about maybe, or all we can see, but the green part is just as important. And it's not really high-level stuff like how do you feel kind of psychology. I'm talking very, very low-level kinds of mechanisms are being disrupted. So it gets all the way down into, things that are analogous to semiconductor device theory and computer chips and things like that on the human side to try to understand how these things can be very tightly integrated. Sorry, I went a few minutes over. Thanks.
We have time for a few questions if people have them.
If anybody needs to escape, I won't won't have my
Yes,
feelings
we
hurt.
won't
So
take
I realize I went over a little bit.
Umbrage.
So you mentioned Pokemon, and from what I can tell, that was a social phenomenon driven by social media
Yeah.
and by a community that organized around social media. So do you see that having influence on the possible applications of virtual reality?
Yeah, no, I think that's absolutely right, and it's something that I don't understand very well, frankly, how it all works, right? But there is this critical, what is it? I would like to say critical mass, but it's kind of an old term. It's critical something. It's like a critical kind of network of people, and something reaches a certain level, and then it spreads like wildfire, right? It's the viral effect, I guess, right? Yeah. And so as soon as there's the right kind of viral apps that are not just a one-time wonder, but really cause people to repeat and keep going back to it, I think we'll be in very good shape. But then how do you get the technology into enough people's hands to where they can play around with it? They can goof around with their smartphones, and that's how Pokemon Go could spread so fast, because the whole ecosystem was already there for that spreading. So on the one hand, we'd like to have that happen, but how do we get it happening before we have all the devices in people's hands? And maybe this continuous path kind of model that Apple and Google are using is sensible in that way, if the killer app comes along. If it doesn't, then they may have some trouble. And who knows, whatever worked holding up your phone, is that going to be the right thing when you go to a wearable display? I'm not sure either. So that's a great question. Yeah.
Any other question?
Yes?
What would it take for a VR system like Oculus to be the primary device for video communication?
Well, video communication is very interesting. I think that, suppose we just want to do face-to-face video conferencing right now, right? So one of the hardest problems in there is that you may have noticed that it's hard to look people directly in the eyes. You look in their eyes, but they don't see you looking in their eyes, right? Because you're looking at the screen, not the camera, right? So that's the beginning of the problem. So when you get into VR, if you're wearing a big goofy headset, then your face is covered up. And so now if you want to have a conversation, you have to both convert yourselves to avatars maybe. But now you're just weird cartoon people. Is that enough? I'm not sure, right? And you could try to get the weird cartoon people to get more and more close to being accurate, but then you have the uncanny valley when you start looking like talking cadavers or something, right? It gets a very strange problem. So that's where the challenges are. People talk about putting cameras inside. Some people have done work like that, putting cameras inside and trying to estimate the face shape, or maybe even trying to take an image of your face and trying to fill in the rest and kind of fix it. But I bet you'll look like you had some horrible accident or something, if you're not careful. It's very hard. The uncanny valley comes into play there. So it can be one way very nice. You can just take a panoramic camera set it up, and have a bunch of people. I imagine like, you know, say grandma wants to go to the birthday party on the other side of the earth, and at the birthday party they set up a panoramic camera, and grandma can feel like she's hanging out there, but no one's going to interact with her because she's just a little camera sitting on the table. So I don't know how to. You can still capture, but it's weird. So a lot of open challenges there, I think. So to me, it's the most exciting use case, really. But that motivated me in the first place to go to Oculus. I really like that one a lot, but it still has its challenges.
The reason I asked is I'll give you a very direct example. I have a 6-month-old. He loves being around people.
Yep.
He would just interact with all of us here. But when I put the phone in front of him and try to interact with grandma and granddad, he doesn't.
Oh gosh, that's right. That's right. That's very interesting. We were living in China this summer, and we were with we brought our baby who was 6 months old at the time, and it was working for her on a phone. Somehow we would set it up, and her grandma was here in Champaign, and they would be going back and forth and giggling and laughing together, and it worked. Some of its personality, sometimes I wonder if it's the size of the screen, but that's a great kind of experiment, right, to do. We could sign up our babies for it. That's right. It's like a Turing test or something of telecommunications for infants or something. You know, can they tell the difference?
I want to stick in a question. You didn't say anything about Google Glass. Obviously, Google Glass was in form factor. I think it met some of the requirements, and in fact matched one of the devices that you said might be a good solution.
The Snap spectacles. Yeah.
But obviously Google Glass failed, and not only did it fail, but it became a major source of both skepticism, derision, serious social concern.
That's right.
So how do we deal with these problems? What do you think is the right path forward?
Yeah, that's exactly right. I mean, the people who are wearing the device, people nickname them glass holes, right? So that part's edited out, right?
I haven't heard that one.
Anyway, so it got to be a problem. I remember at Oculus being able to try it. One of the people in the Oculus team had some kind of early trial membership, and we got to try it out. And I was amazed that it was not as great as I thought it was going to be, even in trying it, because it was a single eye, and I remember having to kind of look at something while looking forward kind of at the same time, and I found that very awkward. Yeah. So like the optical science part wasn't very well worked out. The voice recognition part was really good, and the audio part was really good. It was very expensive relative to the Snap spectacles. I think they're like $100, $150. So it tried to do a lot and pack a lot of technology in. And I think society has changed even in the last 5 years. I think it's more acceptable to run around with a camera in public than it was then. And when Snap made the glasses, they made it so that a light turns on whenever it's activated, so that at least everyone around you knows that the camera's activated. It's just that little bit of subtleties of like a few years have gone by, and they did a little bit to try to mitigate that. It seems to have helped quite a bit. Now, maybe people don't have the Snap glasses everywhere yet, I don't know, but it seems like that's helped a fair amount. There's definitely a sociological problem here, and it's so hard to predict what the herds are going to do next. I learned that too from talking to investors. It's like two words I learned: B2B and B2C, right? So B2B is business to business, and B2C is business to consumer. And they always say business to consumer, wow, that's so unpredictable. Very, very hard, right? B2B, oh, that's easy. Everybody wants to make money. Business one wants to make money. Business two wants to make money. Business one tells business two how to save money on something you're doing. Give them something, it does it, done. You know, consumers, who knows why they spend their money, right? So it's really interesting, right? It's all then the sociological phenomenon comes in, this kind of viral effects, all these kind of things come into play. It's very hard to predict.
Other questions? Did you have a question there?
Yes.
Oh, I can't see the person. Yep.
As AR and VR systems get better and smarter, are you concerned about a future in which people are all wearing just the AR and VR systems, and that's the reality you see? Because I feel like that's always the biggest fear when it comes to...
Yeah, I think that's right. I mean, I think it definitely would lead to a lot of good Hollywood films in a dystopian future and novels. Things have been done like that, of course. Ready Player One is like that, which Ernie Klein came out to Oculus a lot, by the way. It was interesting. And so there's always that possibility, I guess, of technology kind of going the wrong way. When I see people walking around with their smartphones like this all the time, I kind of wonder as well, is that really some kind of positive advancement? So a balance will have to be struck for sure. There's also so many use cases where people who have limited mobility might be able to get out. People who are in maybe in a retirement community, or maybe have some physical disabilities where they might not be able to get out, have a chance to at least go out and interact in some kinds of ways. But if it takes mobility away from some people or causes them to use their muscles less, that's really sad and unfortunate. We've been doing that a long time. argue that the automobile did that a lot, right? We struggle a lot in the U.S. with health problems, I think largely because we've designed society to have everyone just go from car to car all the time, or go from door to door all the time with their cars, right? As opposed to riding bicycles and walking a lot and things like that. So hopefully we can design that in. I think it will have to do with whatever the cultural mindset is of the society that takes in the device. Probably country to country it'll vary a lot, and culture to culture it will.
Yeah, question back there.
Yeah.
Back to the question of interspersed for virtual reality, trying to find what the one balance is going to be. Have you played around with standard neuroscience techniques like electroencephalograms and other brain recording mechanisms, and what are your thoughts or challenges related to that?
I have not played around with it directly. Certainly read some papers relating to this. I think that one of the things to really pay attention to is what kind of acuity you have with different kinds of muscle movements, right? And also, in addition to that, taking into account the comfort and fatigue and things of that nature, right? How much of the cerebellum is devoted to different parts, and how much of the brain is used for different parts can really give you a kind of a sense of that. But I haven't really, and I think that also studying just the differences between one-to-one matchings and learnability. So one thing in that field that's important to look at is motor programs and the learnability of motor programs. Like some motor programs are very complex, very difficult. Like learning to drive a manual transmission is a little bit troubling for some people, but the steering wheel seems to be kind of easy. The mouse seems kind of easy. So in some fields, it may make sense to learn something very complicated, like a neurosurgeon has to learn to use a lot of instruments and it takes a very long time to learn. You don't want that for a consumer device. So what's the right kind of balance, I guess? What are easily learnable motor programs? So I don't know, but the things you're suggesting would be a part of that study. I haven't done it myself.
Any more questions?
Yep.
Yeah.
You sort of spoke a little bit about just sort of hardware and also in terms of like perception. I'm wondering if you know any spaces that they're working with physiological aspects of those. You talk about the inner ear.
Yeah.
I'm wondering if there's any study in terms of manipulating the body in such a way as to sort of change that perception.
Yeah, I think that's right. I mean, in some sense, it's all manipulating the body, right? You're providing artificial stimulation in the visual form, in the audio form. And I did try some device from some researchers at the University of Osaka where they put on some kind of headphone-looking thing, and it electrocuted my my inner ear a little bit. And then they had a joystick, and they could make me walk funny. Like they could start steering me left and right. Felt a bit nauseating and uncomfortable. What's hard there is to pinpoint the vestibular stimulation to the right place. I think you can disrupt it pretty well, but it's hard to make it very precise. Like, okay, you're accelerating at 5 meters per second squared now. I'm going to, in this direction, I'm going to make your vestibular organ feel exactly that. I haven't seen anything like that to be able to control it with that level of precision. So, but that's certainly one possibility.
I was just wondering if anybody's studying that. And obviously, somebody's.
That's right. That's right. It's been a lot of study of that nature. Yeah.
Disrupting it.
Absolutely. Absolutely. There's legal issues sometimes with some of these things, but I think at that level you can get away with it.
Okay, I think we should give Steve a big hand.